So first example, finding the distance from the origin to a point on a graph. Let p equal xy be a point on the graph, y equals x squared minus 1. So that's right here. Express the distance from p to the origin as a function of x. So the first thing we're going to do is recall the distance formula. That's going to be square root x2 minus x1 squared plus y2 minus y1 squared. So we need two coordinates. It does give us 1, the origin. We know that's 0, 0. So I'm just going to note that. So I have 0, 0. And the other coordinate is going to be point P, which is right here, x comma y. Now we talked about this a long time ago, but xy isn't very useful because that's two variables. So what we're going to do is use the formula they give us. That's really important. Instead of x comma y, we're going to write x comma x squared minus 1 because that is the y coordinate. That's a better way to think about this. So again, we're going to erase that and think of it as x comma x squared minus 1. And now it generates a nicer pair of coordinates that is in terms of x. Now let's plug it into our formula. D is equal to square root x minus 0 squared plus x squared minus 1 minus 0 squared. We're going to simplify that. That's just x squared plus x to the 4th minus 2x squared plus 1. And now we have a nice formula, x to the 4th minus x squared plus 1. And we'll highlight that. Here's our nice formula. So now it says B. What is the if x is 0? So B, if x equals 0, plug it in. So if I plug in 0 here, I get rid of 1, which is 1. Now what that means is that if x is 0, the coordinate would be, I can look right here, 0, negative 1. So that's the point we're given. This is saying the distance should be 1. And I can definitely see that is true. That distance right there is 1. What's the next one? C. If x equals 1, D should equal. So plug in 1 right here. Notice how we still get the root of 1, which is 1. And that point, well, that makes sense because if you plug in 1, you get 1, 0. And this red line, that distance is also definitely 1. Still a harder one. D. If x equals root 2 over 2. So this is going to take a little bit of work. So we'll continue this over here. D equals, we're going to plug in root 2 over 2. So root 2 over 2 to the 4th minus root 2 over 2 squared plus 1. So D should equal root 2 over 2 to the 4th power. That would be 4 over 16. And then minus 2 over 4 plus 1. So let's simplify that. And this would be 2 over 4. Let's make that 8 over 16. So add that all together. That is going to be, this is 16 over 16. 12 over 16, which is reduced to divide by 4, 3/4. So finally we get it. That's root 3 over 2. So this is a little more complicated. So if x is root 2 over 2, that point would be, so root 2 over 2, that's approximately like 0.7. So that would be somewhere over here. So we just found that this distance right here, this to this green line, and I'll get rid of this red line. make that nicer. That green line is going to be root 3 over 2, right there. Now let's go to the calc example. So get your calculator ready. A rectangle has one corner in quadrant 1 on the graph given, another at the origin. So this point at the origin is going to be fixed. A third point on the x-axis and the fourth point on the positive x-axis. And notice how one corner is important. One corner is on the graph given. Express the area. So let's write A. The area is going to be A of x. That's going to equal. Well, for any rectangle, we should recall that that's length times width. In our problem here, I can see that this distance here is clearly x. I can write x down. And the height is y, right? Because if the point right here is x comma y, this should be y. Now, we said earlier y is not that helpful, so instead use the formula given right here. That's going to be 25 minus x squared. And right here, there's our formula. So again, think of this as x comma 25 minus x squared. B, what is the domain of A? So for this, we can actually just think about it logically. If it's fixed at the origin and the other point is somewhere in this region, I can see that the smallest value I can use is 0 or anything a little past 0. So we're going to make that parentheses because it has to be bigger than 0, this point. And the furthest it can go is 5, but it can't actually be 5 because then you don't have a box anymore. So it's just 0 to 5. Now C says to graph it. So this is where we go to our calculator. So open that up. If you're here, just hit the apps button, function, and I'll type it in. X 25 minus x squared. Notice I give you syntax error. That's because it doesn't like it when you don't put a times here. So make sure you put a times like that. Now it should take it. Now we graph it. Try to make your window so we can see the quadrant 1, because that's what we care about. Take a screenshot of this, and we're going to drop it into our paper here. Right here. Okay, so here's, I dropped it in. That's what I'm looking at. Here's our graph. It says D, for what value of x is the area largest? So to do this, go back to your calculator. Tap near that vertex, or that max point. Menu function root. Oh, sorry, don't do that. So now that we have our graph in there, let's go back to our calculator. Tap near this max value. Go function extremum. Hit the plus button, and now I can see it. So I'm going to copy this information down and go back to our paper. So right there I can see that's 2.88 comma 48.11. So for D, what we're going to put is the largest area, or the max area. That's equal to 48.11. That's your y value. And it's the important part. You're going to write it occurs at x equals 2. Actually around that 8.9. Let's fix that. 2.89. And that's it.